A very good morning to all of you. Welcome to Wellassa University, Sri Lanka's Center for Value Addition, a university that was built to educate but not to transform. A very good morning. A place where knowledge meets purpose and where graduates are shaped to solve real problems for a real world. Today, that spirit takes an international stage. We are gathered here today for this prestigious occasion hosted by the Faculty of Applied Sciences, a community that has consistently pushed the boundaries of applied research, producing work that doesn't sit on shelves but finds its way into industries, communities, and conversations that matter. Standing at the heart of today's event is the IEEE Wellassa University Student Branch, a community of young innovators who believe that technology is most powerful when it is guided by conscience. It is my privilege and honor to welcome you all to the International Conference on Computing, Engineering and Technology, IMPETUS 2026. Before we proceed further, allow me to introduce myself. I'm Chamali Allipola, and along with me, I'm delighted to have two of our very own students of the Faculty of Applied Sciences, Ms. Samisha Mahagamage and Mr. Hamsat Umar. Together, we will be your host for this inaugural session. This year, IMPETUS stands guided by a theme that goes beyond a statement. It is a responsibility we collectively uphold. Humanity first, steering innovation for ethical impact. Because progress without purpose is only motion without meaning. Today, we are encouraged to reflect more deeply, not just on what we are capable to create, but also on the intention behind our innovation and the people it is meant to serve. To every researcher who submitted their work, to every academic who crossed a distance to be here, and to every guest who joins us today, you are not just attendees of a conference, you are a part of a movement. And with that, ladies and gentlemen, we're delighted to begin the inaugural session of IMPETUS 2026. Over to you, Samisha. You are a part of a movement. And with that, ladies and gentlemen, we're delighted to begin the inaugural session of
Thank you so much, Madam. So, as is our cherished tradition, we inaugurate this auspicious gathering by lighting the traditional oil lamp. This beautiful ritual symbolizes the dispelling of darkness, welcoming the dawn of new knowledge, wisdom, and prosperity. We respectfully invite our respected dignitaries and invitees to step forward to light the lamp as their names are called. We warmly invite the Vice-Chancellor of Wellassa University, Senior Professor Kolita B. Wijayasekara. Our guest speaker, Mr. Dwan Robert, Country Representative of Asia Foundation, Sri Lanka. And Senior Professor H.M.S.K. Herat, Dean, Faculty of Animal Sciences and Export Agriculture. Professor A.S. Ratnayaka, Dean, Faculty of Applied Sciences. Professor K.G.C. Senaratna, Dean, Faculty of Technological Studies. Senior Professor M. Vidana Patirana, Dean, Faculty of Medicine. Mr. A.M.D.B. Navaratna, Dean, Faculty of Management. Deputy Librarian, Dr. T. Pradeepan. The Acting Registrar, Mr. A.J.M.D.N.B. Navala. Professor A.P. Henagamge, Head of the Department of Science and Technology. Dr. J.T. Kure, Head of the Department of Applied Earth Sciences. Professor E.M.U.W.J.B. Ekanayaka, Head of the Department of Computer Science and Informatics. The Conference Chair, Professor K.W.S.N. Kumari. The Conference Secretary, Ms. R.P. Abeyawardena. Our main sponsor representative, Ms. Rukshani Vidyaratna, Senior Program Manager, the Asia Foundation. The IEEE Student Branch Chair for 2026 to 2027, Mr. Gihan Bimsara. The IEEE Student Branch Immediate Past Chair from 2024 to 2025, Mr. R. Siri Veerasinghe. Finally, we invite one of the presenters of IMPETUS 2026 to join in lighting the lamp. Thank you, everyone. also, we would like to invite Professor Rohan Reg for the event. Thank you so much, everyone. So, ladies and gentlemen, now please rise for the University Anthem of Wellassa University of Sri Lanka.
Thank you. Now we invite to the podium the Conference Chair of IMPETUS 2026, an inspiring academic leader who has guided the vision of this conference with a strong commitment to research excellence. Ladies and gentlemen, please welcome Professor K.W.S.N. Kumari to deliver the welcome speech.
Very good morning, everyone. Respected Vice Chancellor, sir, distinguished guests, deans, professors, academic and administrative staff members, and presenters, authors, my dear students, and ladies and gentlemen. As a conference chair, it is my great pleasure and honor to extend warm and heartfelt welcome to the first International Conference on Computing, Engineering and Technology, IMPETUS 2026. IMPETUS 2026 is the pioneering academic initiative organized by Faculty of Applied Science of Wellassa University of Sri Lanka, in collaborated with the IEEE Wellassa University Student Branch. The conference is centered around the theme, Humanity First, Steering Innovative for the Ethnic Impact. This conference emphasizes ethical, human-centered, and multidisciplinary innovations in the field of computing, engineering, and technology. The conference called 4 papers under the 4 major technical tracks. First, data science and artificial intelligence, computing and industrial information systems, robotic, mechatronics, and the embedded system, and science and technology. We are delighted to announce that we received 162 full paper submissions across the 4 stacks. Following the double-blind review process, 61 papers were selected, and today we are proud to publish 41 full papers in the conference proceedings. I am also pleased to mention that IMPETUS 2026 has attracted several international research contributions. We have received the papers from participants representing countries India, Malaysia, Singapore, Australia, Bangladesh, Germany, and the USA. This international conference truly reflects the growing recognized global academic research reach in this conference. As a conference chair, I am especially proud that IMPETUS 2026 marks the launch of the first full paper international conference of the university with the DOI assigned proceedings, which is indeed a significant milestone for our institute as well as university. In parallel with the conference, we are also organizing AI for All workshop series for academic, administrative staff as well as students. In addition to that, a panel discussion session on the future sustainable tech was arranged to further enhance the knowledge and skill of both students and staff. At this moment, I would like to first warmly welcome the chief guest of IMPETUS 2026, the Vice Chancellor of the Wellassa University, Senior Professor Kolita Bandara Wijesekara, sir. I warmly welcome sir to these sessions. It is guest honors and privilege to you are present with us in this special occasion, sir. I also extend my special welcome to all our council members for this present today. And also, it is my great pleasure to welcome our keynote speaker, Professor Brian Handbook, who joined us online from USA. And also, with your busy schedules, thank you very much for accepting our invitation and delivering a keynote speak in this conference. Also, I would like to warmly welcome our guest speaker and main sponsor of the conference, Mr. Johan Robert, country representative of the Asian Foundations. Thank you very much, sir, for your presence today and for your valuable contributions to success with the conference. Then I warmly welcome all our panelists and the panel chairs and also panel members of the technical sessions. And thank you very much for your traveling from various places to representing the different part of the countries and for your very support and the engagement. Then I would like to warmly welcome Deans of the Faculty, Senior Professor Saman Herath, Professor Amila Ratnayaka, Professor Chaturanga Senaratna, and also Senior Professor Mudita Vidan Patirana and Mr. Navaratna. Thank you very much, sir, for your presence today. In addition to, I extend my warm welcome all the directors of the centers and the unit, and professors, head of the departments, librarians, registrar, bursa, academic staff, administrative staff, and Mr. Jagat Kulitika and his teams, and non-academic staff, and all the present today. I would like to also express my heartfelt welcome to all presenters, authors who are presenting their research findings both physically and online today. Finally, I would like to warmly welcome conference committee members and IEEE students community for their dedications, commitment, and making this event very successful. Also, I would like to make the special acknowledgement and warmly welcome Ms. Rukshani Jung, Senior Program Manager, Asia Foundations. Thank you very much, Madam, for your significant contribution and presence today. Finally, I would like to express my sincere gratitude to first Vice Chancellor, sir, and also our Dean of the Faculty, Professor A. Ratnayaka. Thank you very much, sir, both sir, for your valuable guidance, continuous and encouragement, and we are in support for the every stage of the organizing this conference. Both of your leadership and the commitment have been to the Institute of making the impetus as a success. Once again, I warmly welcome to you all to the Impetus 2026, and I wish you the productive and significant and inspiring conference today. Thank you very much. Have a nice day to you all.
Thank you so much, Madam, for those words. So we are now honored to welcome a leader whose dedication to academic excellence continues to shape the great landscape of the Faculty of Applied Sciences at Wellassa University. Under his guidance, our faculty has grown into a space where curiosity is nurtured, research is celebrated, and the students are inspired to think beyond boundaries. So, please welcome to the podium the Dean of the Faculty, Faculty of Applied Sciences, Professor A.S. Ratnayaka. A very warm welcome to you, sir.
Very good morning, dear Vice Chancellor, sir, keynote speaker, guest speaker, and Dean of the Faculties, Registrar, Bursa, Librarian, all the invited participants, including conference chair, track chairs, my dear academic staff members, dear students, presenters, and ladies and gentlemen. And it's my great pleasure and privilege to be here as the Dean of the Faculty of Applied Sciences in this inauguration ceremony of IMPETUS 2026. So it's an international conference on computing, engineering, and technology. IMPETUS is a standard for abbreviation, integration of multidisciplinary pursuit of engineering, technology, and utility of science. So first, I would like to give brief introduction about how this first IEEE conference is happened. Last year, IMPETUS is a generally student journal, magazine. They publish several articles related to their innovation, ideas, and thoughts. So last time I gave a challenge to the IEEE conference chairperson, Mr. Asiri Veerasinghe. If there is possible, next time you can have a student conference as called IMPETUS. So he accepted that challenge. After a few weeks, he discussed with other academic staff members, and he met me, and he and his team met me, and said they are ready to take this challenge. So I appreciate their challenges, and I said I will give my fullest cooperation to success this event. So this is the beginning of the first IEEE conference at the Wellassa University of Sri Lanka. IMPETUS 2026 serves as the multidisciplinary platform to foster intellectual exchange, promote research, collaborative research, and implement solutions that address the real-world challenges. By integrating the perspective from the computing, engineering, and applied sciences, this conference underscores the importance of the holistic thinking and cross-disciplinary engagement in driving meaningful the process. So we believe every time, whatever the situation of the development of the technology, humanity is the first. So we have the wonderful theme. The theme is humanity first, stirring innovation for the ethics impacts. So today, the main keynote speaker is the Professor Brian Hellenbrook. He will join online. He is from the Carleton University, USA. So he talked under the topic of the computational mathematics application and advancement for advancing sustainable energy technologies. Guest address will be developed by Mr. Johan Robert. He's here today, and he's the country representative of the Asia Foundation. So I must thank for the main sponsorship given by the Asia Foundation. So we had the project Cybersecurity Hub at the Wellassa University. So we aligned this IMPETUS workshop and conference aligning with this Cybersecurity Hub as well. So we have the 4 conference track, and we have received, as mentioned earlier, 162 full papers. So we have the very tough and very thorough review process. So initially we accepted only the 61 papers. So 18 were rejected after the reviewing process, and 83 papers were just rejected. So we need to keep the standard of this conference as an international level. So finally, 40 papers accepted for the final publications. So in this IEEE conference, so acceptance rate is about 25%. The conference technical and publication process was conducted in line with the relevant IEEE conference standard and formatting guidelines to ensure the quality, consistency, and the academic integrity to the publication of the research work. So today we, as I mentioned earlier, align 40 full papers, and this will be officially published through the conference proceeding following the completion of the presentation and publication process. Furthermore, all the published papers will be assigned digital objective identification, what we call DOIs, to ensure proper indexing, citation, accessibility, and the long-term academic visibility of the research contribution. So I am confident that discussion, presentation, and the interaction at this conference will generate the impactful insights, strengthen academic and industrial partnerships, and contribute to the global discourse on the ethical innovation. I extend our sincere appreciation to all the contributors, participants, and organization members whose dedication and the hard work have made this event success. I warmly welcome you all to the Wellassa University, and I wish you a productive, inspiring, and memorable conference experience. So finally, this is the last moment that I have to address you as the Dean of the Faculty of Applied Sciences. So I take this opportunity to thank all the stakeholders of the Faculty of Applied Sciences, including Vice Chancellors, Dean of the Faculties, Registrar, Bursa, academic staff members, administrative staff members, and my dear students. And we Faculty of Applied Sciences have maintained steady and effective progress with the great achievement at institutional level, national level, and international level. So thank you very much for your all contribution. Thank you very much again.
Thank you, sir. So we kindly request you to remain on stage as a token of appreciation has been arranged for you. So we now invite the conference chair, Professor K.W.S.N. Kumari, to present the token of appreciation to Professor A.S. Ratnayaka, Dean, Faculty of Applied Sciences.
Thank you so much, dear Madam and Sir. So we now arrive at a moment that carries the full weight of this institution behind it. Our next speaker is the highest academic authority of Wellassa University, a scholar and a leader who has steered this university with vision, integrity, and commitment to make higher education a force for national development. So, it is with great respect that we welcome the Vice Chancellor of Wellassa University, Senior Professor Kolita B. Vijayasekara, to the stage.
Distinguished guests, deans, registrar and all the administrative staff members, heads of departments, professors, conference chair, president of IEEE student branch, the track coordinators, track chairmen, resource persons, students, ladies and gentlemen, physically present here and joining online. Welcome to Wellassa University and wishing you a very good morning. Gives me a great pleasure to see the unfolding of this IMPETUS 2026, the international conference organized by the student arm of IEEE together with the Faculty of Applied Sciences in collaboration of Asia Foundation. I'm very happy to see the progress made by the IEEE student branch over a very short period. This activity was initiated as a student exhibition and limited publication about 3 years ago. And then the dean and the conference chair called on me and then discussed this year's program and requested some funding from the university. So we are, of course, funding the university level events, some that selected, but this is the first time that we have taken a decision to fund a faculty event to this magnitude. So I'm very happy that that decision and the funding came through the Asia Foundation. We are very thankful and has yielded this international conference. And as from the speeches, I gathered that there are about 160 plus full papers presented to this conference, and that alone gives the testament that the recognition that you have gained in the research community, this overwhelming participation and the rigorous process that you have adopted has yielded that 40 odd papers now going to the conference proceeding with a DOI for its visibility and wider publicity. So I'm not going to talk much as that I have to attend another meeting. Once again, congratulations to all who have worked very hard. Conference chair, the dean of the faculty for his leadership, the student arm of IEEE, the chair, the president, and all the members, and all those who have spent time reviewing, finalizing the conference proceeding, and arranging all of this that we are witnessing today. Thank you once again, and I'm sure that you will have a very productive and fruitful deliberation when these presenters make their the presentation based on their publications. And also, the theme will be materialized with the knowledge, generated and imparted today, and our common aspiration towards the humanity and the impactful, ethically impactful innovation. Thank you very much once again. Have a nice day.
Thank you, sir. Please remain on the stage for the token of appreciation. We now invite the Dean of the Faculty, Faculty of Applied Sciences, Professor A.S. Ratnayaka, to present the token of appreciation to our Vice Chancellor, Senior Professor Kolathabi Wijesekara.
Thank you so much, sir. So, ladies and gentlemen, we have heard from the voices that shaped this institution, and now we mark a milestone. So, the proceedings of IMPETUS 2026 represent months of hard research, careful thought, and academic dedication from researchers and scholars across disciplines and across borders. So, it is now our privilege to witness the official launch of the IMPETUS 2026 conference proceedings. As this compendium of research is officially launched, we are now moving to a ceremonial presentation. We respectfully invite the Editor-in-Chief, Dr. Subhash Aryadasa, along with the co-editor, Dr. Nimila Dushyanta, to formally present the official copy of the IMPETUS 2026 conference proceedings to our Vice Chancellor, Sir, Senior Professor Kolathabi Wijesekara.
Thank you very much, gentlemen. Now we have reached the moment that many of us have been looking forward to, the keynote address of IMPETUS 2026. To formally introduce our esteemed keynote speaker, Professor Brian Hillenbrook, I'm honored to invite the head of the Department of Science and Technology, Professor A.P. Henegamage, to the podium.
Very good morning to everyone. Respected Vice Chancellor, sir, the Deans of the faculties, distinguished guests, respected academic members, invited speakers, researchers, students, and all participants of IMPETUS 2026. It is my great honor and privilege to introduce our keynote speaker, Professor Brian Hillenbrook, a distinguished scholar, educator, and researcher from Clarkson University, United States. Professor Hillenbrook served as the Painter-Krugman Endowed Professor in Engineering Science Simulation and Associate Dean of Graduate School at Clarkson University. He is affiliated with Mechanical Aerospace Engineering, the Center for Advanced Material Processing and Mathematics, reflecting the deeply interdisciplinary nature of his academic work. His academic journey is truly impressive. He earned his Bachelor of Science degree in Mechanical Engineering from the University of Notre Dame, followed by his PhD in mechanical engineering from Princeton University. After his doctoral studies, he continued his research career as a postdoctoral researcher at Stanford University, working on advanced computational simulation. He has also served as a faculty fellow at NASA Langley and NASA Kennedy, further demonstrating the national and international relevance of his work. Professor Helen Brooks' research lies at the intersection of computational mathematics, engineering simulation, fluid dynamics, heat transfer, and high-order numerical methods. His work focuses on developing and applying advanced numerical simulation techniques for complex fluid flows and thermal processes. In particular, he has made important contribution to adaptive arbitrary Lagrangian Eulerian methods and high-order finite element methods, enabling more accurate and efficient simulations of single-phase and multi-phase flows. The impact of his work extends across a wide range of engineering applications, including solidification modeling for silicon and aluminum manufacturing, droplet and spray modeling, aerodynamic optimization, ducted wind turbine design, and renewable energy-related manufacturing processes. His research on horizontal ribbon growth is especially meaningful as it addresses computational and engineering challenges connected to producing low-cost single-crystal silicon wafers for solar cells. So this is a powerful example of how advanced computational mathematics can directly support sustainable energy technologies. Beyond research, Professor Helen Brooke is also a dedicated educator and mentor. Clarkson University records his teaching recognition, including the University Distinguished Teaching Award, and highlights his long-standing contribution to the supervising graduate students and advancing research training. His keynotes is especially meaningful for IMPETUS 2026, which emphasizes ethical, human-centered, and multidisciplinary innovation. Professor Helen Brooks' work beautifully reflects this spirit. It shows how rigorous mathematics, high-performance computation, and engineering innovation can be brought together to address real-world challenges in energy, sustainability, manufacturing, and society. So, ladies and gentlemen, it is with great respect and pleasure that I invite Professor Brian Hellenbrook to deliver his keynote address. So, Professor Hellenbrook, the floor is yours.
I'm honored to be invited to speak at this conference. I'm very impressed with everything the students have put together. It's been fantastic so far, so I hope to carry that forward. So today I'm actually going to talk about some of the themes of the conference. Let me see if I can share my screen. Is it possible to share my screen? Let's see here, it seems to be disabled. So while we figure out what's going on with the screen sharing, I'll just talk a little bit. So my background is computational mathematics. I do a lot of high-order numerical methods. I'm a mechanical and aerospace engineer, and my research is on developing numerical methods, but also applying them. And so what I wanted to talk about today was applications of how applications and development of new numerical techniques go hand in hand. So that's sort of the message that I'd like to convey. And I still can't share my screen. Anybody have any idea how to fix that? Can anybody hear me? I'm not actually sure what's happening right now. Oh, that seems better. Let's try it now. There we go. Okay. Thank you. From the introductions is basically this drive towards ethical solutions and letting applications guide your research. And I found this quote, which is, "Necessity is the mother of invention." It turns out no one really knows where that quote came from, but maybe it's sort of related to something Plato said long, long ago. But what I'll talk about is how, in my own research, basically, like, applications have led me to new problems and new advances. And so the context of this will be three sort of applied problems that I got involved in. One is crystal growth, production of silicon wafers for solar cells. So it's to produce green energy using the sun. The second one is a funny little problem that I got involved in because of a person that I was talking to in the gym. So oddly enough, it just kind of came up. But that's part of also sort of my message is collaboration is a great way to get into new and interesting problems. And the last one is ducted wind turbines, which is an area that I kind of got into because of another person that was interested in that. And all these things have helped me do new and interesting things. So I thought I would just explain what horizontal ribbon growth is, for starters. For solar cells, you need to make a silicon wafer. And it's best if that wafer is single crystal, which means that the crystal structure is uniform through the entire thing. And this wafer here, I don't know if you can see my mouse or not, is about 150 microns to 300 microns thick. And horizontal ribbon growth produces that. You basically melt a pool of silicon, you impinge a cold helium jet on the surface, and that starts solidifying the silicon. And then you create the sheet and you continuously pull it. And because it's growing here and you're pulling it, it sets up a steady production process. And so that's what horizontal ribbon growth is. It's a process that's not been commercialized. So I got involved in this because of a company that was trying to commercialize this. And it turns out that what happens right at this triple junction point is key for understanding the physics. And so I'll talk a little bit about that and sort of what that's led to me to and sort of developing new numerical methods. So my job in this role is to do simulations. And so I typically do things with high order finite elements. So this is HP finite elements. This is the basis you would use on a triangular element. And typically you use high order basis, so maybe up to p equals 4. And then I'll show you some moving meshes and solidification fronts, free surfaces, all sorts of complex physics that you can include in this. It's not really the point, but it's kind of fun to see. And then I'll show you some of the solutions that come out of it. So this is the basic setup to simulate horizontal ribbon growth. This is the pool of molten silicon. This is a solid sheet. This blow up right here shows you where the helium jet comes out and impinges on the growing silicon. So you're basically solving Navier-Stokes equations in the liquid and the gas of helium, and then you're solving kind of convection and diffusion in this solid sheet right here. And so that's how you simulate the production process. And just to kind of give you a feel for the crazy things that happen, this is a simulation my postdoc made of Marangoni effects in horizontal ribbon growth.
Shows you the velocity field, this middle one, and then the upper one shows you the temperature field. I'm going to hit play, and you can sort of see that this becomes a chaotic flow. There's a jet because of the Marangoni effects, which impinges on the surface. That drives these unsteady oscillations, and you get these oscillations in temperature, these moving jets, and that actually causes the thickness of the sheet. You can kind of see it moving here to vary, which is a big problem for production. And so this simulation actually helped them understand what they were coming up against and trying to make a steady production process. Let's stop that. And so that's just kind of gives you a feel for horizontal urban growth. But what I want to talk about is how getting involved in these applications brought me to new sort of numerical techniques and developing new sort of computational techniques. So we were studying the triple junction, which is shown in this inset here, and we were trying to understand the physics of that point because that point controls the entire rate at which you can produce these ribbons, which actually determines the commercial value of the process. So I was doing a grid refinement study of this and trying to understand what happens, and this is actually sort of an estimate of the percent error in those calculations with the number of degrees of freedom. So this is just me trying to understand how accurate my calculations were. And you can see these are huge percent errors, so like 30% down to 20%. And this is we're going up to 1 million degrees of freedom in a 2D calculation, which is kind of crazy. And then on these is with a polynomial basis of 2, and this is a polynomial basis of 4. And you can see this is the convergence rate. I'm getting a convergence rate of 0.2, and you should be expecting for p equals 4 to get a convergence rate of either 4 or 5, depending on what you're measuring. So something has gone horribly wrong here. And this was my first sort of inclination that we might have a problem. And so this is kind of applications driving some sort of innovation in terms of developing new ways to simulate things. So that was one thing that was happening. At the same time, I was doing another problem, and this is the problem that I was actually in the gym talking to a guy in physics, and he's like, can you solve eigenvalue problems? And he came to me with this eigenvalue problem, and I was like, well, sure, I can solve that. And that's kind of the fun of doing numerical work, is you get involved in all sorts of different things, which, I don't know, helps you learn a lot of new things too. So this problem I was supposed to solve, and they wanted to get the solutions, the physicists wanted solutions to 8 significant digits. So it was a real strain on accuracy. And I knew there was an analytic solution so this cotangent of psi determines the shape of the domain. If it's 0, it's a rectangular domain. If it's square root of 2, you get this funky shaped domain like this for the eigenvalue problem. And so I started looking at that, and I did sort of a validation case. And this is just that square domain where cotangent of psi equals 0. And with p equals 4 polynomials, I got 8 significant digits of accuracy. The answer should be 2. And you get 1.99999 to 8 significant digits. And so that was great. I was super excited. I was like, okay, everything's working. And then I switched to this problem, which had this different shape domain. And suddenly, instead of 8 significant digits, I went down to 5 significant digits, so somewhere around in here. And I lost 3 orders of magnitude of accuracy, and actually, I had a finer mesh than I did on that other one. So this became sort of another application, which was sort of driving me to think about new ways to simulate sort of these partial differential equation solutions. And the reason that this actually starts happening is I'm starting to understand why it happens at this point as I'm looking at these problems, is that because of these boundary conditions, this is supposed to be constant temperature and this is supposed to be a vertical temperature gradient. The second derivative of the solution goes to infinity at this point, and that's what we call a singular point. So it's really that you have a singular point in this domain that suddenly you're losing all of this accuracy. And instead of having a nice high-order finite element method, you're actually getting just typical first or sometimes even lower than first-order accuracy. And then I'll show you one more application just for fun. This is another one that I got involved in, which was actually ducted wind turbines. So again, producing green energy. It's hard to see in here, but there's a disk here. This is an axisymmetric calculation. So there's a disk here. The flow is from bottom to top, and it goes through the disk. The disk is an actuator disk which models the blades of the turbine. And that creates a wake here, and you get this typical wake expansion, which is because the flow here is slowed down because you've drawn energy out of it. And so you apply a pressure jump to model the blades, and so that's just given by delta P as some function of the velocity across the rotor disk. And this is a nice way to do fast calculations, and what we were doing it for was ducted wind turbines. Ducted wind turbines have been shown to create more power per unit area than in just a standard open rotor. And so we were looking at that for possible emergency applications where you need to deploy power into remote applications. And so we were trying to figure out how to optimize the duct to create the most power as possible. And so that's the application. And then as I started to look at this, this is actually the pressure near the actuator disc. So this is the actuator disc here. This is the high pressure upstream, low pressure downstream. And you can see that at this point, the pressure is actually discontinuous. It goes from red to blue in zero distance. And so this point is also a singular point. And so again, the applications are leading me to something which is showing me that we need something different to simulate this stuff, because this thing is not even converging at first order accuracy, even though I have all these higher refined elements. So we have a problem, and the applications have led me to the problem. And so next what I'll talk about is an innovative solution. And I'll have to say, like, these kinds of things have happened to me all throughout my career. You know, I get involved in an application and you find challenges, and those challenges lead you to new research questions. So all three of the applications have singular points. All three have suboptimal convergence. And so, as I said here, we need new techniques for numerically simulating problems with singular points. Okay, so I'll just give you a little quick overview of what happens at the singular point and why these things go badly. This is the typical form of this behavior near a singular point. You get this r to the lambda, and lambda is typically non-integer, so it's like 1.2, for example, which means that you take the derivative of it, and that goes to infinity, either first or second, depending on the value of lambda. If lambda is 0.6, for example, then the derivative goes to infinity. If lambda is 1.2, then the second derivative goes to infinity. And those derivatives going to infinity cause your solutions to not converge. And as an example of that, this is just an analytic solution based on that sort of decomposition. And I'll show you a calculation which 100% converges what I just told you. So I do a mesh refinement study, and these are the convergence rates. This is L infinity norm, which is the maximum error over the domain, and this is the L2 norm over the domain. This is with p equals 1, p equals 2, and p equals 4. These are all supposed to converge at different rates. So it's first order, second order, and fourth order. But they all converge at exactly the same rate, and that rate is 2/3 for the L infinity norm, which is really slow, and 4/3 for the L2 norm. So again, that verifies that that doesn't work. And so then I started really thinking about different ways to do this, and I'm pretty excited about this possibility. So instead of using, this is the idea that I have for sort of solving these problems. Instead of using XY coordinates to do the simulations, we're going to switch to a new coordinate system, which I call theta and rho. Theta is your typical theta, which is the angle around the singular point. But rho is the log of the radius divided by some outer radius. Okay, so that's a logarithmic coordinate in radius. And because r goes to 0, rho goes from negative infinity to 0. And so if I map that solution for the singular point into those coordinates, it becomes e to the rho lambda, and then some sine and cosine of theta. This function is infinitely smooth in those coordinates. So unlike the other functions which we looked at, which had derivatives that went to infinity, this function is infinitely smooth. And the only problem is that the domain goes to negative infinity, so I modify slightly the dimension of rho so that it truncates at basically log of r epsilon over r0, which is like a negative number. So you have a negative number to 0, so you have so instead of going to negative infinity, you go to some finite negative number. And that will be, on that domain, this function is infinitely smooth. So let's see how that works. So this is the domain now. Instead of this domain, the one we were working on before, we're working on this rectangular domain. This is the theta coordinate, and then this is this new rho coordinate, which in theory should go to negative infinity, but I've cut it off and truncate the domain. And so I'll do a mesh refinement, so the calculations being done on this domain. This is just showing you what this domain looks like in physical space. And then do a mesh refinement again, and again, and again. And these are now the errors. So this is p equals 1, and that actually is converging with first order accuracy. This is p equals 2, which is converging with second order accuracy. And this is p equals 4, which is converging with fourth order accuracy. So now suddenly I'm getting fourth order accuracy. These things plateau a little bit, and that's because of that truncation of the domain. So if I don't truncate the domain, and if I truncate the domain at a much longer distance instead of -8, -16, then those errors shrink and I get basically fifth or fourth order convergence, second order convergence, and first order convergence for all my resolutions. And so that is how applications have sort of helped me develop this new technique for simulating problems which have singular points. And we're kind of going, this is now future work, but where we're going with this is that we're going to wrap a domain, or this would be an airfoil calculation, which airfoil calculations are probably the most important calculations in all of aerodynamics. And it turns out that this point is a singular point. And so for all these years, even trying to use higher order methods, airfoil calculations have not converged with higher order accuracy. And it's because this point is singular. So what we're going to do is use 3 distinct coordinate systems. This domain will have an arc length coordinate system plus a row coordinate system, which is similar to what I used on the other domain. So this will be a log of r coordinate. Here I'll do the same thing. It'll be log r theta, just like I did in the previous one. And then we have to match these boundaries together, but that's not really hard. You match just like a periodic boundary. You can match across here and here. And then you have to do some sort of mapping from this curved domain into the normal physical domain here. I'll show you what that looks like here. So this would be the outer domain. This is being done in XY coordinates. This is the rho S domain, which is kind of that boundary layer mesh, which is wrapped around the airfoil. And then this is rho theta, which is that trailing edge mesh, which is right at the tip of the thing. And in physical space, it looks like this. So this is the S rho coordinates. This is the rho theta coordinates. And then this is the XY coordinates. And these all have to be coupled across these boundaries. And so these calculations are now being done in these different coordinate systems. And that actually works just fine. So this is a moderately low Reynolds number calculation of flow over an airfoil. And you can see all the behaviors coupled together. And then if I look at the pressure, you can see that now I'm starting to resolve the singular pressure behavior right at the trailing edge. And I haven't actually finished this. This is still kind of ongoing work, but I'm hoping to show you that in the future that we'll have high order convergence to problems for airfoils with sharp trailing edges, which would be the first time that that's been done. So I'm pretty excited about that. So to conclude, for the students out there, I think applications and collaboration are key to innovation. So a lot of these problems, weren't my idea, right? I kind of was talking to someone and they said, hey, we could use your help simulating this. And I got involved in that. And I think, I knew really very little about these problems before starting. So I encourage the students to kind of, be open to new things, to take the things that and apply them in new areas. I think that's the way that we make most of our advancements, is by moving into new areas, into bringing new tools into places where they haven't been applied before. And so just be willing to attack new challenges and take on those sort of scary new problems that you don't really know that much about. And I would say that over my career, this is just one example, but this has happened to me many, many times, where I get involved in something and I realize, oh, you know what? We don't know how to do this. We need to do a better, we need to be able to do this better. And so, I just find it to be quite fun. So I wish you guys all the best, and I hope that the conference goes well. Thank you very much for the invitation, and I'd be happy to take any questions. If I can.
It seems like they don't get any questions. So thank you, Professor Hellenbrook, for your valuable insights.
Thank you very much for inviting me.
So behind every conference like this one, There is a story, months of preparation, countless hours of coordination, and a shared belief that bringing minds together creates something greater than any one of us could achieve alone. So we now invite you to sit back and experience that story. Please direct your
thank you for
attention to the
inviting me.
screen for the Impetus 2026 conference highlighting video.
No problem, no problem.
The sharing.
Yeah, no problem, no big deal. Thank you very much for everything. Good luck with you guys. We'll see you later.
See you later. Thank you so much.
Just give us 5 minutes till they fix the technical issue, please.
Until we fix that technical issue, let's move forward. So now to formally introduce our distinguished guest speaker for today, Mr. Johan Robert, whose presence adds great value to this occasion through his experience and expertise. I'm honored to invite the head of the Department of Applied Earth Sciences, Dr. J.T. Kure, to the stage.
Distinguished guests, deans of the faculties, registrar, bursa, and other academic and non-academic staff of the university, and students and delegates of the IMPETUS 2026. Good morning to all of you. As we gather here today at the intersection of the technology and entrepreneurship, our goal is to explore how research can transcend to solve most pressing challenges of our time. To guide us in this exploration, we are incredibly honored to invite a guest speaker who has spent his career at the very heart of social transformation and regional development. It is our honor to introduce Mr. Johan Robert, the country representative of the Asia Foundation in Sri Lanka. Johan is a visionary leader with over 2 decades of experience across South Asian landscape. From his early work in peace building and conflict resolution to his strategic leadership role in Cambodia and Maldives, he has consistently championed the idea that progress is only sustainable when it is inclusive and data-driven. At the Asia Foundation, Johan oversees a vast portfolio that addresses the complexities of the modern era, from strengthening sub-national governance and promoting gender equality to navigating the frontier of digital resilience and cybersecurity. For this audience, Johan's perspective is vital. He reminds us that the research we conduct and the data we analyze do not exist in a vacuum. They are meant to serve people, to provide justice, and to build more resilient communities. Mr. Johan's roots in peace studies from the University of Bradford and his extensive experience with the British High Commission and the International Alert give him a unique vantage point on how technical innovation can be force for social good. So ladies and gentlemen, please join with me to welcome Mr. Johan Robert to the podium as our guest speaker.
Good morning. every 39 seconds, somewhere in the world, a hacker successfully breaches a network. By the time I conclude this address, more than 15 major cyber attacks will have occurred globally. We have moved far beyond the era where cybersecurity was relegated to a back office IT concern. Today, it is a pillar of national security, economic stability, and fundamental personal privacy. And I would add, it is increasingly a question of social equity, as those with the least resources are often the ones with the least protection. Good morning again, and it's genuinely an honor to be here at Wellassa University today. On behalf of the Asia Foundation, I would like to extend our sincere gratitude to Vice Chancellor Senior Professor Kolita B. Vijayasekara for his leadership and for his warm welcome. I would also like to warmly thank Professor Amila Ratnayaka, Professor Kumari, and their team for the exceptional organization of this conference. Events like this one that brings together students, academics, and practitioners around subjects as critical as cybersecurity are exactly the kind of investment in our collective future that Sri Lanka needs. It is a privilege to contribute to that conversation. As we stand in 2026, the global cost of cybercrime is projected to exceed $10.5 trillion annually. This landscape has been fundamentally reshaped by the rapid evolution of artificial intelligence. While we leverage AI for defense, threat actors are utilizing it to automate phishing campaigns and orchestrate deepfake social engineering attacks that are virtually indistinguishable from legitimate communications. And we've seen that play out very actively in Sri Lanka over the last few weeks. A phone call from your bank, a voice message from your child, an urgent email from your CEO, none of these can be taken at face value anymore. The era of simple password theft has been replaced by a more insidious reality. 90% of breaches now involve compromised digital identities. In this environment, your identity, not the network, is the new perimeter. Turning our attention to the domestic front, Sri Lanka is at a pivotal juncture. As we aggressively transition towards a digital economy, targeting a 12% contribution to our GDP by 2030, our attack surface has expanded proportionately. According to Sri Lanka CERT, we have witnessed over 12,650 reported incidents in the last year alone, and that number represents only what is reported and what we know. The true scale is almost certainly far, far greater. The most vulnerable among us are often the first to be targeted. Our elderly citizens face impersonation scams where AI mimics the voices of loved ones to solicit emergency funds. Our youth are increasingly exposed to cyber harassment and manipulation on social platforms. Our small and medium enterprises, the very engine of our economy, contributing over 50% of national output, frequently find themselves one ransomware attack away from permanent closure. And as our rural communities embrace digital services for the first time, they are being targeted by predatory fraudulent loan schemes and fake employment offers circulated through social media. So these are not abstract statistics. These are real people, as you know, with real livelihoods and with real consequences. So this is precisely the space where the Asia Foundation has chosen to act. As an international non-profit organization working across Asia and the Pacific, the Asia Foundation has long recognized that cybersecurity is not merely a technical challenge, it is a development challenge. and development challenges require community-level solutions. Through the Asia-Pacific Cybersecurity Fund, made possible with support from google.org, and in partnership with the Cyber Peace Institute and the Global Cyber Alliance, the Age Foundation is working along with our partners in Sri Lanka to strengthen the cyber capabilities of over 300,000 underserved micro and small businesses, nonprofits, and social enterprises across 13 locations or 13 countries in the Asia-Pacific region. Here in Sri Lanka, the mission is being translated into tangible action. In Sri Lanka, the program aims to educate and equip 13,000 micro, small, and medium businesses with the skills necessary to navigate cybersecurity threats through training sessions along with the university here that have been planned across all 9 provinces. That means a batik seller in Kurunegala, a tech startup in Jaffna, and an agri-exporter in the Uva province all have access to the same foundational cyber knowledge. A key component of this initiative is the development of a structured cyber hygiene online course delivered through suhurusara.lk, a dedicated learning management system, ensuring that essential cybersecurity knowledge reaches businesses and students in a scalable and sustainable manner. The curriculum covers cyber hygiene practices, digital risk awareness, and practical tools, not theoretical frameworks written for IT professionals, but accessible, applicable guidance for everyday business owners and first-time digital users. The program also pays special emphasis on women in a bid to enhance participation in economic activity and ensure that digital inclusion does not replicate existing inequalities in society. We are proud to be doing this work here in partnership with institutions like the Wellassa University. Because universities are not just centers of learning, they are multipliers. The students in this room today will become the entrepreneurs, the civil servants, the engineers, the policymakers of tomorrow. And the cyber habits that you form today will shape the resilience of this nation for decades to come. Sri Lanka is not a passive observer at the national level either. We are implementing the National Cybersecurity Strategy, and the progress is measurable. We hope that the Cybersecurity Bill, which will establish a National Cybersecurity Agency, will be enacted soon to help enforce mandatory data protection and security standards. In conclusion, digitization is the essential engine of Sri Lanka's future growth. We aspire to a paperless government and a tech export sector valued at $5 billion. But while digitization is the engine, cybersecurity is the braking system. In high-performance environments, we do not have brakes to slow us down. We have them so that we can safely navigate at high speed. The work being done by government, by universities like this one, is building that braking system. But it only works if every one of us takes personal responsibility for our part. So let us embrace this digital revolution with both ambition and vigilance. Together, we can build a nation that is not only highly connected, but deeply resilient. Stay connected, stay informed, stay vigilant. Thank you very much for your patient listening and wishing you a successful conference today. Thank you. Thank you very much for your patient listening and wishing you a successful conference today. Thank you.
Thank you so much, Mr. Joanne Robert, for those updated speech. So as a mark of our gratitude for your presence and your words today, we would like to present you with a token of appreciation. So for that, we respectfully invite the Dean of the Faculty of Applied Sciences, Professor A.S. Ratnayake, and our conference chair, Professor K.W.S.N. Kumari, to step forward and jointly present the token. The Dean of the Faculty of Applied Sciences, Professor A.S. Bhatnagar, and our conference chair, Professor K.W.S.N. Kumari, to step forward and jointly present the token. Thank you so much, everyone. So, can you please direct your attention again to the screen for the IMPETUS 2026 conference highlighting video. Thank you so much, everyone. Conference highlighting video. Thank you so much, everyone.
Thank you. Every moment of this inaugural session, from the first light of the oil lamp to the powerful words that we have heard, has been made possible by the dedication and tireless efforts of an extraordinary team working behind it. It is now time to pause and acknowledge that with the gratitude it deserves. Please welcome to the podium the Conference Secretary of IMPETUS 2026, Ms. R.P. Abeyewardena, to deliver the vote of thanks. With the gratitude it deserves. Please welcome to the podium the Conference Secretary of IMPETUS 2026, Ms. R.P. Abeyewardena, to deliver the vote of thanks.
Vice Chancellor of Wellassa University, Senior Professor Kolita B. Wijesekara, esteemed guests of IMPETUS 2026, council members, deans of the faculties, librarian, Wellassa registrar, representatives from Asia Foundation, academic and administrative heads, organizing committee of the IMPETUS 2026, authors, presenters, participants, and my dear students, ladies and gentlemen, wishing you a very good morning at the beginning. IMPETUS 2026, International Conference on Computing, Engineering and Technological, organized by the Faculty of Applied Sciences of Wellassa University in collaboration with IEEE Student Branch. So it was initiated with the vision of creating multidisciplinary collaboration and meaningful academic engagement, conducted under the theme Humanity First, steering the innovation for ethical impact. So the IMPETUS 2026 brings the innovation and also all the researchers, academics, industry professionals, and students to share their academic researches. At this memorable occasion, it's my great pleasure and honor and privilege to deliver the word of thanks on behalf of the organizing committee of IMPETUS 2026. First and foremost, even though he's not in the seas, so I'm like to express my sincere gratitude to our Vice Chancellor, Sir, Senior Professor Kolita B. Wijesekara, for having confidence in us to achieve this success in IMPETUS 2026 and guiding us everywhere and whenever we wanted. So thank you so much to our Vice Chancellor, Sir, for his support and unwavering support he's giving to us. So following that, I like to extend our deepest appreciation to the Dean of Faculty of Applied Sciences, Professor Amila Ratnayaka, so for his valuable guidance, continuous encouragement, and the unwavering support provided throughout the journey of organizing IMPETUS 2026. Sir, your vision, leadership, and the guidance have been truly valuable, and it is the guiding light behind this successful event. So we warmly thank you for your contribution and support. Also, I will take this as an opportunity to thank all the deans of the faculties and head of the departments and the academic members who are present today for this inaugural ceremony of IMPETUS 2026. Also, we are deeply honored by the presence of our esteemed guest, keynote speaker of IMPETUS 2026, Professor Brian Hellenbrook, Professor in Engineering Science Simulation, Associate Dean of Graduate School, Clarkson University, USA, who is joining online today here with us from USA. Thank you so much for our keynote speaker. Also, I will take this opportunity to thank Mr. Johan Robert, country representative, the Asia Foundation, who is with us today and who will be have given already a very insightful speech for the audience. We also extend our sincere appreciation to all the invited session chairs, technical session panel members of the 4 tracks and the 5 technical sessions which will be about to begin, and the distinguished members joining today for the panel discussion. Your expertise and academic presence at immense value to technical and intellectual discussion of the conference. Furthermore, we would also like to extend our sincere appreciation to all sponsors and supporting partners who have contributed to our conference success. In particular, our deepest and most special appreciation goes to Asia Foundation for their unwavering and tremendous support through our this session. We are especially grateful for Ms. Rukshani Vidyaratna, Senior Program Manager of Asia Foundation, and Mr. Johan Robert. Once again, I thank you both of you to coming here and supporting us to make this conference actually a success. At the same time, we thankful for other sponsors as well as who have sponsored this event, like Western Paper Industries for partnering with us with this IMPETUS 2026 and their generous support for the conference arrangement. Also, we like to extend our heartfelt gratitude to Microtech Biological Private Limited through financial assistance to support the success of conference journey. Meanwhile, our sincere appreciation goes to the IT unit, also the audio-visual unit, and especially Mr. Jagat Kulatilaka and his dedicated team to provide the continuous technical support and operation to make the conference technical arrangement. Also, we like to thank our media team of the conference IMPETUS 2026, along with the leading of Mr. HPDP Patirana. So I would like to thank his team as well for the technical support throughout this conference. At the same time, this heartfelt thank is also extended to all the organizing committee members of the IMPETUS 2026 who are contributed to the success of the conference through numerous activities throughout the program. Also, we are thankful to all the academic members, administrative heads, and the university non-academic staff who supported us in numerous administrative, technical, and operational matters. Further, to all the authors and presenters of IMPETUS 2026, thank you for your valuable research, contribution, and choosing IMPETUS as a platform to share your scholarly work, ideas, and innovations. Additionally, we warmly acknowledge all our online and physical participants joining us here today. Your participation truly strengthens us the collaboration to do multiple disciplinary researches, knowledge sharing, and this is the spirit of our conference. Finally, the most important and our very special the gratitude goes to IEEE student branch of the UWU for initiating this vision and the idea behind the IMPETUS 2026. So what began was as an idea with the ambitious students and the students who are working with IEEE branch of UWU, now it has become a reality. So today here you can witness that reality through IMPETUS 2026. So with their numerous and dedicated hard work, now we are here today by inauguration ceremony of the IMPETUS 2026. Like we are going to initiate with the conference of Faculty of Applied Sciences. In this regard, we sincerely thank for the former chairperson, Mr. Asiri Veerasinghe of IEEE student branch, and the current chair, Mr. Gihan Bimsara, the current chair of the IEEE student branch, and his team, members, and the volunteers who are organizing this conference event. A very special appreciation also extended to the student development team of the IEEE branch for successfully developing the IEEE IMPETUS website, and also my thank also goes to the designing team who have done a contribution by designing a very creative content for our conference. Last but certainly not, We would like to thank everyone who worked tirelessly behind the scenes, even with the small responsibilities and unseen arrangement within the conference site. The technical support, logistics, welfare activities, and every supporting task carried out with the dedication and commitment. Your every single contribution has made valuable in making IMPETUS 2026 a reality and a success. As we officially commence IMPETUS 2026, we hope that this conference will be meaningful discussion, valuable collaboration, innovative idea, and memorable experiences for every present, everyone here today. So wishing you all the very best and good luck with your technical sessions as well, and wishing you all a very fruitful engagement and successful conference day. And thank you very much. So wishing you all the very best and good luck with your technical sessions as well, and wishing you all a very fruitful engagement and successful conference day. And thank you very much.
Thank you so much, Madam. So now, ladies and gentlemen, we have reached the close of the inaugural session of IMPETUS 2026. What began with morning with the lighting of the oil lamp has grown into something far greater, a gathering of minds united by a single powerful conviction. So, to our distinguished guests, our keynote speaker, our faculty, and every researcher present here today, thank you for being part of this moment. And to every participant joining us virtually from across the world, your presence reminds us that knowledge has no borders. So, ladies and gentlemen, we now invite you to rise for the national anthem of Sri Lanka. And to every participant joining us virtually from across the world, your presence reminds us that knowledge has no borders. So, ladies and gentlemen, we now invite you to rise for the national anthem of Sri Lanka. Thank you so much, everyone. So the inaugural session of IMPETUS 2026 is now formally concluded and refreshments have been arranged. So we warmly invite all staff members, academics and guests to make your way to the lobby of the Staff Learning Center. And for the students, your refreshments will be served here at the auditorium. So following the refreshment break, we kindly request everyone to return to this venue by 11:15 a.m. as the panel discussion will commence here promptly at that time. So we will look forward to seeing you back in this hall.
Ladies and gentlemen, can I have your attention, please? So before we wind up the session to have a group photograph, may I invite all the distinguished guests